Okay, there's just one more video just about average rate of change because it seems like something that people could use a little more help on. So here I have an example. It says profit from concessions can be modeled by the function P, where P of T is the total profit T hours after opening. So here's my T hours, and I have this in here, and you can see where I've actually already labeled the change in here because I know it's going to be helpful. And here it says, what is the average rate of change of total profit between T of zero point 0.5 and T of 1.5? We're going to show work and include units. So my formula is just that I'm going to subtract my function values, my y, the p of t, so p of t2 minus p of t1 divided by t2 minus t1. When I do that, 62 minus 22 is my y values, and then 1.5 minus zero point 0.5, which is just 1. So I get $40 dollars per hour because those are my units. Dollars were on top, hours are on the bottom. The second one, they want me to estimate the rate at which total profit changes at t equals 1.8, and they want me to explain. So 1.8 happens in between 1.5 and 2. So when I do that change, I would get 110 minus 62 divided by 2 minus 1.5, and I would get here 48 divided by zero point 0.5, which is 96. So that's $96 per hour. And I used my explaining, I used this interval because this was the smallest interval containing 1.8 hours. And kind of the idea is that I can't really find an exact rate of change at like a single point because it's not constant. But the smaller my interval, the better estimate I'm going to get. So if I get smaller and smaller intervals, I can get better estimates. And one other thing to note about this problem is that if I was looking to see if this was like linear, it is definitely not. One thing I look for here is along the top, my time intervals. These were equal intervals. If they're not equal intervals, I can't just check the change. I have to like check the ratios. And then here I can see those, since these are all the same and these are not, this is clearly not a linear relationship. All right, everybody, good luck, and I'll see you soon.